A groundbreaking new study analyzing the gut microbiomes of more than 70,000 adults has uncovered compelling evidence that certain bacteria may play a crucial role in maintaining cognitive sharpness as we age. By mapping microbial communities and correlating their abundance with memory and executive function tests, researchers have identified specific brain-friendly bacterial strains that tend to decline over time, potentially contributing to age-related cognitive changes. The findings are exciting because they suggest that supporting these microbes through diet, lifestyle, or targeted interventions could become a practical and accessible strategy for preserving memory, focus, and overall brain health across the lifespan. The study drew on a diverse population of adults aged 20 to 90, using high-resolution genomic sequencing to create detailed microbiome profiles. Participants also underwent standardized cognitive assessments, evaluating memory recall, attention, processing speed, and executive function. By analyzing patterns across tens of thousands of individuals, researchers could identify microbial signatures consistently associated with better cognitive performance, even after controlling for confounding factors like age, sex, education, and overall health. The scale of the study allowed for unprecedented statistical power, giving confidence that the identified bacteria are not coincidental but likely meaningful contributors to cognitive outcomes. Among the most significant findings was the identification of several bacterial genera whose abundance was positively associated with memory and mental agility. These microbes are particularly adept at producing short-chain fatty acids, SCFAs, such as butyrate, which support gut barrier integrity, reduce systemic inflammation, and modulate neural signaling. Butyrate and other microbial metabolites play a key role in the gut-brain axis, helping to maintain optimal neurotransmitter balance, support synaptic plasticity, and protect neurons from oxidative stress. Adults with higher levels of these bacteria consistently outperform their peers on memory tests, suggesting that nurturing these microbial populations could be a tangible pathway to cognitive resilience. The study also revealed that the abundance of these brain-friendly microbes declines naturally with age. While some reduction may be influenced by genetics, diet, antibiotic exposure, and lifestyle factors, the overall trend suggests that age-related shifts in the gut microbiome could partially explain why memory and cognitive flexibility tend to diminish over time. This insight is particularly encouraging because it implies that microbiome-focused interventions, such as prebiotics, fermented foods, fiber-rich diets, and potentially next-generation probiotics, might help maintain or even restore these beneficial bacterial populations, offering a practical means to counteract age-related cognitive decline. Importantly, the study highlights the broader implications of gut health for overall mental performance. Beyond memory, higher abundance of these protective microbes was linked to sharper attention, faster processing speed, and more effective problem-solving. Participants with richer gut microbial diversity reported fewer mental fatigue symptoms, better emotional regulation, and improved day-to-day cognitive efficiency. These findings underscore that a healthy microbiome is not just a digestive asset, it actively supports the brain, influencing mood, learning capacity, and resilience under cognitive stress. Dietary and lifestyle strategies emerged as actionable ways to support these brain-friendly bacteria. Diets rich in fermentable fibers, whole grains, legumes, and fermented foods like yogurt, kefir, and kimchi were consistently associated with higher abundance of these beneficial microbes. Regular physical activity, adequate sleep, and stress management also appeared to bolster microbial diversity, reinforcing the principle that multiple lifestyle factors work synergistically to support gut and brain health. This holistic perspective empowers individuals to take concrete, everyday steps that can positively influence both their microbiome and cognitive function. The research also offers exciting possibilities for future personalized interventions. With more refined microbiome mapping, clinicians may one day identify individuals whose microbial profiles put them at higher risk for cognitive decline and recommend tailored dietary or probiotic strategies to cultivate protective bacterial populations. Such precision approaches could enhance preventive care, helping older adults maintain sharper memory, better attention, and more resilient neural networks. The study's large-scale approach lays the groundwork for these future innovations, providing a robust dataset to guide both clinical research and practical health guidance. Beyond individual benefits, the study underscores a positive, proactive narrative about aging and brain health. While cognitive decline is often seen as inevitable, The identification of specific bacteria that support memory and decline with age highlights that biological pathways influencing cognition are modifiable. By nurturing these microbes through diet, lifestyle, and potentially supplementation, individuals can exercise agency over their cognitive trajectory, demonstrating that aging need not mean passive decline, but can involve active cultivation of mental vitality. In conclusion, the mapping of gut microbiomes in over 70,000 adults has revealed a set of brain-friendly bacteria strongly linked to sharper memory, attention, and cognitive flexibility. The natural decline of these microbes with age provides both a mechanistic explanation for some aspects of age-related cognitive change and a promising target for intervention. By supporting these bacteria through fiber-rich diets, fermented foods, and healthy lifestyle habits, older adults may be able to preserve memory, enhance mental clarity, and strengthen cognitive resilience. This research represents a major step toward understanding the gut-brain connection at scale and offers a hopeful, practical path for maintaining brain health throughout life, showing that what we feed our gut can profoundly shape the way we think, remember, and stay mentally sharp.